We're going to take a look at 7.127 and 7.131. This has to do with probability density functions again, but this time it's when the information we're interested in has a normal distribution or bell-shaped curve. So this is just a problem without context. This one here, 7.127. Here's a graph of a normal curve with a mean. Again, in a normal curve, the mean is always in the center, in the middle. And then we map out the distribution of the values. And then we can answer questions about what's the probability that the value would be 98 or 102 or greater than 104. And so to answer questions like that, we need to know the normal probability distribution function. What does it look like? And in this case here, we would see the mean's 100 and then the standard deviation would be 2. And again, it's related to the empirical rule, but those are the values for this normal curve, which is again representing a probability density function, which we then look at the interpretation here on 7.131. The answer I put in for us here, but looking at the first question, here's the normal curve. Suppose you collected some data where the mean was 69, standard deviation 17. And so in this case, this is what the normal curve would look like. And then we could answer probability questions with respect to the area underneath the curve. It's an idea related to the empirical rule about the number of standard deviations values are from the mean. And so there's the drawing of it. And then here's the region that's shaded in. So there's the region that's shaded in that represents the values, all the values for the cell phone charges less than $52. So on average, the average bill is $69, standard deviation 17. So you'll see some bills would be over 120, some would be less than 18, but most of them will be in the middle. And again, how many in the middle? Again, that's related to the empirical rule, meaning 68% of the bills would be from 52 to 86. But many times we want a more exact answer, and so this is where we would come into play some of these ideas. And so here's the shaded region, and then suppose the area underneath this curve is 0.1587. What would that mean? It goes back to our note sheet. And so if you have your notes and you did the video notes, or you would have this here, if you have these notes from the videos or from lecture, you would see that the area underneath the curve has two interpretations. One, it's the proportion of the population with that characteristic described by the interval, or the probability that a randomly selected individual from the population will have that characteristic. So it's important to recognize that. So now when we look at this, what's the interpretation? What this means is that 15.87% of phone bills are less than $52. Or you would say if you randomly selected one phone bill, the probability that it's less than $52 is 15.87%. And if I wanted to replicate that on StatCrunch, we could. When you open up StatCrunch, instead of the uniform calculator that we did earlier, you go to the normal calculator. You put mean 52, standard deviation was 17, and I want the probability that it was less than 52. Compute. Messed up, not 52. The mean was 69. What's the probability it's less than 52? Compute, and there's your 15.87. And again, the 69 came from, and the mean is 17 from the standard deviation from our problem here, and that's where you would get that.